Chapter 2, Section 1, Scientific Notation. Today we're going to talk about scientific notation, which can be used whenever we are working with really large or really small numbers. So the first thing I'd like you to do is I'd like you to write down the key concept. The key concept is on page 66 in your book, which you should have open. The key concept is a number is in scientific notation if the first factor is greater than or equal to 1 and less than 10, and the second factor is a power of 10. So these are our three examples. 1 times 10 to the 8th power, the first factor is equal to 1, 10 to the 8th power is a factor of 10. Our second number, 1.54 times 10 to the 7th, again, my first factor is greater than 1, and my second factor is a power of 10. And my third example, 9.9, which is less than 10, and my second factor is a power of 10. Please pause the video and write the key concept along with the three examples into your notebook. When you're finished, restart the video and we'll start example 1. Example 1. 1.55 times 10 to the 7th degrees Celsius. This represents, in scientific notation, the temperature of the sun's core. Now, if I wanted to rewrite this number, 1.55 times 10 to the 7th degrees Celsius, as a number, I'm going to move the decimal to the right 7 times. Because if my exponent is 7, it's like multiplying 10 7 times. I'm going to move that decimal. So I would have 1, 5, 5, 0, 0, 0. I'm just going to put some zeros on here, and now we're going to move that decimal. So my decimal was here, and it's going to move 1, 2, 3, 4, 5, 6, 7 places to the right. So my final answer would be 2, 3, 4, 5. 1, 2, 3, 4, 5. Would be 15,500,000 degrees Celsius. Now, just because we're working in scientific notation, if you were given units, please don't forget those units in your answer as well. So, again, moving from a number in scientific notation to a standard number, you're going to move the decimal the number of places of your exponent. Okay? Looking at example 2 this time, we're given a number in standard form, and I want to move it into scientific notation. So I'm going to take this decimal, and we're going to move it. That will stop. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 places. Because remember, my first factor has to be greater than or equal to 1, but less than 10. I'm going to keep the 3, the 5, and the 3. As part of my number. They don't just go away because I'm moving them into expanded form. They're going to come down here as part of my number. They're just going to be to the right of my decimal this time. And then my second factor is going to be a power of 10. I moved that decimal 14 times, so my exponent is going to be 14. So writing this number, 135,300,000,000,000 in scientific notation, 1.353 times 10 to the 14th power. So, two key things to remember here. Number one, that your first factor is greater than 1. But less than 10. And it does not have to be a whole number. It can have a decimal. So that 3, 5, and 3 is going to stay as part of my problem. It's just going to be to the right of the decimal. And then my exponent is how many places the decimal moved. Okay? All right, example 3. Next page. So here I have a number in scientific notation, 1.23 times 10 to the negative second power. So when we are writing very small numbers, if you look back at the previous page, both of these are very large numbers, 13 billion or 135 billion, excuse me, even larger. Okay, 15 million. Those are both very large numbers, and the exponents are both positive. However, when we're working with very, very small numbers, we can have a negative exponent. And what that means is that we're going to move the decimal moves left. So if I have 1.23, I'm going to move that decimal 2 places this time to the left. 1, 2 places to the left, and I'm going to put a 0 as my placeholder in the tenths place. So my answer here would be 0 or 0.0123. Okay? So this then is less than 1. Again, moving my decimal to the left. In example 4, we are going to take a number that's written in standard form, 0.12345. So this is a very, very small number. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 10 millionths. So this is 76 100 millionths. Very, very small number. But I want to write this in expanded form. So this time I'm going to move that decimal 1, 2, 3, 4, 5, 6 places. So my first factor becomes 7.6 times 10, 1, 2, 3, 4, 5, 6, but this time to the negative 6th power because I'm moving that decimal to the right. This is less than 1. So whenever a number is less than 1, the exponent in scientific notation will be negative. Okay, that's it for the examples. Please go and do the 4 quick checks and then complete your check your understanding, and we'll go over those first thing in the morning. Have a great afternoon.